Sometimes we don't have an x squared that's easy to isolate because the x is trapped inside of a squared binomial like what we see in each of these. So instead of foiling that out and gathering like terms and then trying to refactor it, we can still solve these problems using square roots. So I'm going to do exactly that. I'm going to just take the square root of both sides as it is. Since that x minus 2, that whole parentheses, is being squared, I can undo that square with a square root. So I get just x minus 2 over here on the left. On the right-hand side, I still need to have that square root of 9 with a plus or minus in front of it, and then of course the square root of 9 is 3. So I'm now, instead of having x equals plus or minus 3, I've got x minus 2 equals plus or minus 3. So then I have to still isolate the x, and so I'm going to do that by adding 2 to both sides. But this is where we have to be careful. I'm not just going to add 2 to the 3 and make it plus or minus 5, because really this is two separate answers, 3 and negative 3 when we took the square root. So I'm going to add 2 to 3, and then I'm going to add 2 to negative 3. So I'm going to write this as 2 plus or minus 3. And so now I have two separate operations that I have to perform. I'm going to do 2 plus 3, which is 5, and then I'm going to do 2 minus 3, which is negative 1. And so there are my two answers. If we just add the 2 to the 3 the way it is right now, without recognizing that it's a positive 3 that 2 is being added to and a negative 3 that 2 is being added to, then we're going to end up with plus or minus 5 as our answer, which we can see is not correct. We can verify this by just plugging in these numbers and seeing what we end up with. But if we were to plug negative 3 in for, or negative 5 in for x up there, we would definitely see that that's not correct. In the second example, I'm going to do the same thing. I'm going to take the square root of both sides. So I've got 3x minus 1 equals, and now square root of 36 is 6, but I of course need the plus or minus. So now I'm going to add 1 to both sides, but I'm not going to add it to the 6 and make it plus or minus 7. It's going to stay 3x equals 1 plus or minus 6. And now at this point I could either perform those operations, or what I'm going to opt to do is I'm going to divide both sides by 3 right now. Because what that sets up for me is I've got x equals 1 plus or minus 6 over 3. And so now I'm going to perform those two operations to generate my two answers. I'm going to hold off and do that until after I've got the x isolated. So I go 1 plus 6 is 7, so I'm ending up with 7/3 as one of my answers. And then I go 1 minus 6, which is negative 5, so I get negative 5/3 as my second answer. So it's just a little trick to not do the 1 plus or minus 6 too early and get the two answers that we then divide later. We could do the division first and then do the plus or minus to close things out. So sometimes we do need to isolate that squared binomial before taking the square root of both sides. So we can see that circumstance in both cases here. So before taking the square root, I'm going to divide both sides by 9. So now I'm left with x plus 4 squared equals 45 divided by 9 is 5. So now I'm ready to take the square root of both sides. So I'll go ahead and do that. So we get x, whoops, try that again. We get x plus 4 equals the square root of 5. I can't do anything with that. It doesn't factor anywhere. It's not a perfect square. So I'm going to just leave it as plus or minus root 5. And so this actually ends up being less work than if we could have taken the square root, because now my last step is to just subtract 4 from both sides. And so we get x equals, now these aren't like terms, so I'm not going to be able to perform that plus or minus operation. So I'm just going to write my answer as negative 4 plus or minus square root of 5. For the last one, we'll go ahead and do the same thing. We've got to work on isolating that x plus 4 squared. I'm going to treat it as if it was a giant variable that needs isolating. So I'm going to add 4 to both sides. So I've got 2 times x plus 4 squared equals 128. So now I'm going to divide both sides by 2. So I've got x plus 4 squared equals 128 divided by 2 is 64. And now to close things out, I'll take the square root of both sides. I get x plus 4 equals plus or minus 8. Got to have that plus or minus. And so then we finish out by subtracting 4 from both sides. So I've got x equals, once again, don't just do 8 minus 4 or negative 4 plus, we have to do negative 4 plus or minus 8. This time, unlike the previous one, we can actually perform the operation, so we need to do it. So negative 4 plus 8 gives us 4 as one of our answers, and negative 4 minus 8 gives us negative 12 as the second